Good day, guys. So today we're supposed to solve this question. It says write the differential equation governing the mechanical system and then determine the transfer function. So the first thing is let's start with J1. So when you apply the torque in this direction, what's going to happen? The inertia is going to try and oppose the torque, the inertia J1. The damper here is going to try and oppose the torque, and the spring will also try to oppose the torque. So that will be, it's sum of applied forces is equals to sum of opposing forces. So in this case, the applied forces T of T should be equals to, the first one is J. So it should be, J is kind of like mass, so mass and acceleration, but in this case we're dealing with angular rotation, so it should be J1 d square theta T is theta 1 we're dealing with over dt. Now rather than writing this, I'll just write theta dot 1 plus the second, this thing that will affect is B12, so it's B12. But notice that B12 is connected to this and this, and it's affected by the rotation of both J1 and J2. So it's going to be theta, because it's velocity. Let me write it as velocity first so I won't confuse you. Over dt. In this case, since we are working in reference to 1, let's write 1 minus d theta 2 t over dt, which is the rotation of the second inertia. I'm writing this, I'm just going to write theta dot 1 minus theta dot 2. So this is velocity plus k is from angular displacement. So it's simply going to be, k is in between the two of them, so it's going to be theta 1 minus theta 2. We take the Laplace of this double differential. You can see it here, sorry, not there. This will be j1s square theta s plus b12 s theta 1 s minus b12 s theta 2 s. You can see at this point they just keep forgetting to add this s here, that's all. K theta 1s minus k theta 2s. Now simply just factorize common factors. J1s squared plus b12s plus k, everything multiplied by theta 1s, minus b12s plus k theta 2s equals to t of s. So this is our first equation. But in order to make it easier for us, I'm going to simply assign this to A. This will be A theta 1 S minus, and then I'll assign this to B. So B theta 2 S equals to TS. Now for J2, let's see the forces that will affect it. Torque that is being applied is only, the motion is however given by this damper, this spring, sorry, this damper and this spring, and as well as its own inertia. So it's going to be j2 theta dot as angular acceleration plus b theta dot, sorry, it's not theta 2, it's just theta. I didn't realize that before. Plus this damper also oppose the motion 1 to theta. In this case, since we are talking in relation to theta, it will be theta minus theta 1 dot, because it's angular velocity we're dealing with, plus the spring, that's the spring, to be theta minus theta 1. I'm sure tempted to say theta 2 all the time, equals to 0. So now we can just change it to Laplace, so it will be j2 s squared theta s plus b theta s plus b12 S theta s minus b1 to s theta 1s plus k theta s minus k theta 1s. Now simply just factorize. So now we can make this c, but remember that this is same thing as b from the last equation, from the first equation. You can see it at this point, it's the same thing. So it's simply going to become minus b theta 1s plus c theta s equals to 0. And the first equation is equation 1. So now what we're supposed to find is theta s over ts. So look in the equation to find where you can find theta s and ts in the same equation. You can see it here. So we need to find a way to substitute out theta 1s. So make theta 1s of the formula in this particular equation is going to be theta 1s is equals to c over b theta s. Substitute it into this equation is going to become a c over b theta s minus b theta s plus ts. Since this is repeating, I'll just factorize it out and take LCM. So it's going to be over b ac minus b square theta s equals to t over s. You cannot just get the transfer function. So theta s over ts will simply be the reciprocal of this b over ac minus b square. Now just simply substitute back what ba and b was. So this is going to be your final answer. Thank you for listening. Hope you understood.